Yes, hello everybody. I'm OJ, or Ole Jørgen Maeland is the actual way to pronounce my name. I can understand that's kind of hard for Americans. Yeah, this presentation is supposed to be about what happened to orbital systems. I would like to start with a question I often get from people. So why would somebody move from beautiful Tromsø, Norway, to something like and exchange this for this? Okay, it's more to it than that. Tromsø has got a lot of this. Makes it easier to want to move. This is actually in late April a few years ago. And we got a lot of this. So that's my son outside insisting on trying out his new gas grill in mid-May this year. Okay, so orbital systems. I would like to start and go back and say a little bit about the start of the company. So it was founded in 2004 in Irving, Texas, to design and build the best antenna systems in the world. And it was co-located initially with the city company Quorum Communications, which focused on RF product feeds, receivers, and stuff like that. Quorum was, by the way, was founded in 1988 by two of the same people who founded Orbital Systems. So that was Rick Fogel and Alan Buntons, and then Carl Schoenberger came into the to join them to start Orbital Systems. So in 2007 we moved into the new facility, so where we still are today in Irving, At that time, it had adequate space for production and building of the antennas. We have been growing a lot over the last years, and our facility is starting to be too small for us now. So we are looking on different ways to cope with the bigger demand. I'll come back to that. All right. So both companies, Orbital and Quorum, was privately held by the founders until they were purchased by CPI in 2018, August 2018, and became part of I think it was the CPI Antenna Systems Division, ASD. Things happened with CPI over the last few years, and we were fully merged into CPI, SATCOM, and Antenna Technologies last March. So now we are not Orbital Systems anymore. The official name is CPI SAT, Orbital Systems Operations. But, well, we go by Orbital Systems either way. So, and we have also had a struggle to keep the logo. The Orbital System logo. CPI is trying to get rid of that, but we are fighting to keep it. Okay, so over the years since Orbital was founded, I would say we have a product base of at least 300, maybe 350 antennas in the field worldwide. Deployments are both in the commercial market, government, and defense markets. However, the biggest part of the market of sales are to the commercial market. Like at the time now, it's more for ground station service providers. And we started out with a 2.4 meter EOS-DB antenna. We have now a much bigger antenna, a variety of antenna sizes, going from 1.5 meter up to 7.3 meter, which is the latest and newest and the new kid on the block. So So the markets we are penetrating now is the biggest market is the TT&C, telemetry tracking and command market. So we ship at least 4 antennas per month to satellite this service provider, ground station service providers, TT&C antennas. They operate for make operations for small sat markets, but also the traditional space markets are looking into starting using these service providers. Our second large market is the EOS-DB market. It used to be the biggest, but now it's the second. So that's the EOS-DB, EOS, search and rescue, and general scientific missions. And then we have a small market where we supply positioners for radars or different defense contractor projects. All right, so the antenna positioners, everything is designed in-house. Orbital Systems do design everything from ACU, the control bus and all that. We do the RF part, feeds, down converters, all the onboard electronics. Yeah, I mentioned the ACUs, but also high power amplifiers for the TT&C antennas. And the last thing we are working on now is auto track systems for the bigger antennas. And we have also developing now the monitoring and control software for that is formerly known as the EOS-DB, EOS-FES system. I mean, we were also making a more generic MNC system for controlling the antennas and also third-party equipment like matrices and all the demodulators. Okay, so this is just to give you an idea of the deployment of our antenna systems. The blue dots are the EOS-DB systems, which you can see more or less all over the world. We have the yellow TT&C systems with a huge constellation up at Svalbard. So you can probably guess who that customer is. And we have a few other type of systems out there, and we have a lot of undisclosed systems. Some of them are for 3-letter agency customers. And yeah, so the sizes, as I said, is from 1.5 to 7.3 meter, and that is so we have 5 different positioner sizes, which can take different dish sizes on it. The most normal for the EOS-DB are the 2.4 ABP that can be delivered with a 2.4 or a 3-meter dish. Okay, so EOS-DB reception system. What is that? So it is the antenna, either a 2.4 or a 3-meter, L and X band feed, and they are prepared for all the direct broadcast satellite missions. And customers are typically national weather services, universities, and other entities which support specific applications. So over the last 5 years, a good estimate is that Orbital System has provided 95% of all sales in that market. Okay. So the 2.4 XLD EOS-DB reception antenna system. So it's so this is the antenna, the positioner, 2.4 or 3 meter. It's got a 2.4 meter single-piece aluminum reflector, or optional a 3-meter 2-piece reflector. There is also an alternative with a composite, but that's expensive and doesn't give you any more value for it. So one of the key factors for the long lifetime design of the antenna is the pressurization. So this will keep the internals of the antenna dry and stop any humidity from entering the system and prevent corrosion to happen. So that's why we can say that the antenna's lifetime design is like 25 to 30 years. And the ACU is automatically managing the internal humidity. So if your humidity gets too high, it will open a purge valve in the feed to push out the humid air, and the dehydrator will provide new dry air into the cabinet. So everything inside the antenna, including the feed and electric cabinet, is pressurized. Okay, so the X and L feed are built have built-in LNA and LNB and dump converters, built-in dielectrics, which combines the X and L band into one single coax to reduce the number of cables you need to pull. And it also optional comes with S-band if that is of interest. So we can actually make a 3-band antenna, XL and S-band. And for longer distances between the positioner and the indoor equipment, we recommend the optional RF over fiber module system we have developed. Yeah. Okay, so the indoor components are D300 demodulator, the front end server, the EOS server, and the DHR150 dehydrator. The dehydrator has to be mounted inside in a non-frost environment. And there's an optional half rack which comes with a monitor keyboard, KVM switch, and a 5 kVA UPS, which is capable of running, providing the antenna, running the antenna and the server and everything for, I don't know, Judd, 20 minutes, half an hour? Yeah, or a couple of hours, yeah, in case of power outage. And also the rack has the capacity for extra equipment. If you need some extra storage or extra processing server, there's space in the half rack for that. So a few words about the new D300 demodulator, which was released a couple of years ago to replace the HRD and LRD 200s. So the LRD and HRD 200s have kind of come to the limit of what they can do in data rates. So I think the maximum data rate is like 50 megasymbols per second, or maybe 40. So some of the new satellites have a higher data rate than that, and like the METOP SG. And the FY3E will also probably, I'll come back to that in a later slide. Okay, so let's just speed up through this. The D300 is one of the big advantages. It's remotely upgradable, and it's easy to add new modes for new satellites. Yeah, and it comes with a spectrum analyzer and a scatter plot, which you can see through a web page on the D300. Front-end server. Okay, let's look at that. I think I will skip most of that and go directly to the operating system. It's a Linux CentOS 7 are still in use until this end of this year, and we are working on the Rocky Linux 8, and the port of the EOS Fast into Rocky Linux is about 98% complete. The service we are now shipping with VMware, so the EOS Fast is running as a virtual machine, and it also comes with a sound server, a VM, for data storage. And there is room for more virtual machines on it. So this is something we've been talking to Liam about, to maybe add the CSP preprocessing environment as a third virtual machine on the server. It's only a matter of adding memory and a good CPU on it. Yeah, so I took this slide just to show some of the screenshots from the EOS Fast, the NOC main screen, this scheduling, satellite pass log. So after the pass is gone, there's a lot of logs and plots from the pass, status, and image data is also, you can watch the image data through the GUI. Okay, so preparation for coming missions. For JPSS-2, the HRD 200 can still handle the data rates, but you may need a firmware upgrade for adding the JPSS-2 mode, depending on when it was delivered or shipped from our factory. No other hardware upgrades are necessary for JPSS-2. Method SG, on the other hand, will require the D300. It will require a feed upgrade to open up the pre-LNA filter from 120 MHz to 200 MHz. The Method SG downlink bandwidth is about 150 MHz. So that's why you need the wider filter. Feed can either be returned to the factory to be upgraded, or we can work with the customer remotely to assist with the filter upgrade. It's not super hard, but there's some tricks you need to know about. FOS3E, we just looked into the ICD we got from Liam, and it seems like, first of all, you will need the D300. The HRD 200 cannot do it. And the feed may have to be upgraded, but that has to be confirmed. It looks like maybe the bandwidth is 130 MHz for FOS3E, but that has to be confirmed. Okay, so I just wanted to show our new baby. The 7.3 meter is a fantastic antenna. It looks really good. We have installed the first one in Korea at K-Water. We have the second one running outside. It will be shipped to Svalbard. And the third one will be built up. It's actually under building right now and will be shipped to South Korea later this year. So there's a huge demand for these antennas. Yeah, and it even moves. All right, so a few last words. The reason why I came to Orbital Systems. Customers come first at all times, both in sales and service. It's a fantastic organization. It's a lean processes, and it's a short way between from the customers to the support, or the persons actually working and designing the stuff. Fast response to customers, very high system reliability, long service life, products that are easy to maintain and diagnose, and if you look at it from on the big picture, it's the lowest long-term cost of ownership, even if the price is a little bit higher in the first investment. All right, thanks.
stream.
No more, yeah. No more.
Do we have any questions for OJ? Yes.
I'm curious if you have any lead time challenges right now in the supply chain as screwed up as it is.
Yes. That's a short question, short answer to that. Yes, we have lead time issues, but it's both for the supply chain issues, but also the high demand we have. So we used to ship like 2 antennas per month a few years back. Today I'm trying to push out 8 antennas every month. So we have we have several challenges with upscaling the production and getting parts through, and even getting fatted test and verification of the antennas. So yes, we have lead time issues.
Hi, I'm Jen. Talked from Gina.
Yeah.
We have one of your antennas. It's been wonderful at CDAS facility. I was wondering, what approach do you have to take installing antennas in the Arctic now? So we had a big rain snow event in December, and we got a lot of ice on the radome from our antenna, and you just blocked the signal. So I was wondering, when you install antennas in difficult places, what kind of approach do you take to protect them and think about the performance in a changing climate?
Yeah. So well, the biggest precaution you can take is to put a radome over the antenna. But of course, as you say, ice and snow can build up on the radome. The easiest solution to that is to, when it's snowing or blowing snow, there's a snow rope which is attached to the top of the radome, and just walk around the radome with that a couple of times before the ice builds up. I mean, that's the best.
It's interesting. We have one of those with the rain or snow that happened during the holidays, and
Yeah.
it was so dangerous. The FCS operators were staying home, and it really struck me that this can be a challenge.
Yeah.
Moving ahead as we get these different weather events in the Arctic.
Yeah. Yeah, it's a very known problem. I don't know if I have a super good answer to that, but yeah, it's.
Well, it's been great. Thanks for working with Orbital. It's been excellent customer service. As I mentioned from Judd the other day, it's great.
Yeah, and I was going to mention that, and that's the best publicity or PR we can get. It's customers being happy and spreading the good word. So thank you for that.